Welcome back, guys. Today we are going to continue our lesson on special right triangles, and today it's about the 30, 60, 90 right triangle. So we've got angles of 30 degrees, 60 degrees, and 90 degrees. Okay, so in a 30, 60, 90 triangle, the hypotenuse is 2 times as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. Okay, so here's how this looks. The shorter leg has to be across from the 30, and that is going to be 1. The hypotenuse across from the 90, that's the longest side, that's going to be 2. And across from the 60 is the medium side, and that is the square root of 3. Now, if we look at our calculator, and we just evaluate the square root of 3, we get 1.73. So that is bigger than 1, but smaller than 2. So it's the medium side, which is across from the medium angle. Okay? Shortest side is across from the smallest angle. The longest side is across from the largest angle. So we're going to find the value of each variable, and every 30, 60, 90 is similar by angle to every other 30, 60, 90. Okay, so we have 8 is to the square root of 3. So those are the medium sides. So 8 is to the square root of 3 as x is to 1. Okay, so our cross products, we don't even really need cross products. We have x over 1. Okay, so x is by itself. X equals 8 over the square root of 3. Now, to simplify this, we multiply the square root of 3 on top and bottom. So we get 8 times the square root of 3 over, and then the square root of 3 times the square root of 3 is the square root of 9, which is 3. 3 does not go evenly into 8, so that will be our final answer. Okay, now we also have 8 is to the square root of 3 as y is to 2. Okay, so I can do cross products and divide. I can also just take this and multiply it across here and get y by itself. So I get 8 times 2 over the square root of 3 equals y. Okay, now I have to multiply by the square root of 3 on top and bottom. Okay, so I get 16 times the square root of 3. And then square root of 3 times the square root of 3 is 3. And 3 does not go evenly into 16, so that is my final answer. You make a guitar pick in the shape of an equilateral triangle. So the guitar pick looks about like this, and it has side lengths of 32 millimeters. What is the approximate height of the guitar pick? Okay, now an equilateral triangle has angles of 60, 60, and 60, but this 60 is split into two 30s. Okay, so we've got a pair of 30, 60, 90 triangles. And on this 30, 60, 90, I've got a hypotenuse of 32. I have a shorter leg of 16, half of this side here. Okay, and what I want is this height. Okay, now I can use my 30, 60, 90 triangle here, and I'll do hypotenuse is to hypotenuse. 32 is to 2 as the longer leg, h, is to the square root of 3. Okay, now, just like I did here, instead of doing cross products and dividing, since my h is on top here, I can just take what's on bottom and multiply it across here. So I have 32 times the square root of 3 over 2 equals h. Now, 32 is divisible by 2. So I get h equals 16 times the square root of 3. Okay, now that would be an exact answer. But it says approximate and a guitar pick. We're talking about a real life object. So an approximate answer is definitely appropriate here. So 16 times The square root of 3 is 27.71. So the height is 27.71 millimeters. All right, find the value of x. Okay, so the value of x is on the longer leg. The longer leg is to the square root of 3. So x is to the square root of 3 as 2 times the square root of 3, which is the shorter leg, is to 1. Okay, now I'm just going to take this number and multiply it across. X equals 2 times the square root of 3 times the square root of 3. And the square root of 3 times the square root of 3 is 3. And that's all over 1. Okay, so 2 times 3 over 1 is 6. So x is 6. Okay, find the height of the triangle. Now this triangle is just a basic triangle. It's not any particular real world object. It doesn't say approximate, so we are going to leave an exact answer here. Okay, so we have sides of 12, 12, and 12, which means this is an equilateral triangle, 60 degrees here, 60 degrees here, and up here is 60 split in half, so it is 30. So here's a 30, 60, 90 triangle. Let's use this short leg this time. So 6 is to a short leg, 1. As h, which is the longer leg, is to the longer leg here, square root of 3. Okay, now let's just multiply this across, and we get 6 times the square root of 3 over 1 equals h. 6 times the square root of 3 over 1 is 6 times the square root of 3. Okay, a car is turned off while the windshield wipers are moving, and when you do that, the windshield wipers just stop right where they are, and they happen to stop here in a way that makes a 60-degree angle with the bottom of the windshield. So here is a 60-degree angle. So we're looking at a 30, 60, 90 triangle right here. How far from the bottom of the windshield are the ends of the wipers? So that means x is right here, from the end of the wiper to the bottom of the windshield. Okay, now x is the longer leg, so that compares with root 3. So x is to the square root of 3 as the hypotenuse compares with this hypotenuse, which is 2. So the hypotenuse is to 2. Okay, so I've got x on top, so I'll just take what's on bottom and multiply it across. X equals 24 times the square root of 3 over 2. And 24 is divisible by 2, 12 times the square root of 3. Okay, so that is the exact answer. But this is a real-world example, and in real-world examples, we give measurements in approximate answers with decimals. So 12 times the square root of 3 is 20.78. So 20.78, and this is in inches. Okay, so what if, instead of stopping at a 60-degree angle, it stopped more like this, and it was a 30-degree angle? Then, how far is the end of the wiper from the bottom of the windshield? Okay, the wiper is still 24 inches long. Okay, but now this time we're looking at the shorter leg, so x is to 1. As the hypotenuse, 24, is to 2. Okay, x over 1 is x. It's already solved. Okay, 24 over 2 is 12. 12 inches. Okay, now on the back page, we're going to do this just like we did the 45, 45, 90s in the previous video. So instead of drawing one of these every time and doing 1, 2, square root of 3, I'm just going to write numbers onto each triangle. Okay, short leg is to 1, long leg is to root 3, hypotenuse is to 2. Okay, so my proportion is b is to 1, as 12 is to 2. Okay, so b over 1 is b. 12 over 2 is 6. Okay, so I've got a short leg of 1, hypotenuse of 2, and a long leg of root 3. So e is to the square root of 3, as 15 is to 2. Okay, so underneath this e, I have a square root of 3. I can just multiply that across. E is 15 times the square root of 3 over 2. And 15 is not divisible by 2, so I just leave it just like that. Okay, short leg is to 1, hypotenuse is to 2, long leg is to the square root of 3. So I have r is to the square root of 3 as 9 is to 1. And I can take what's under that r and multiply it diagonally across, and I get r is 9 times the square root of 3, and that's over 1, which is just 9 times the square root of 3. Okay, short leg is to 1, hypotenuse is to 2, long leg is to the square root of 3. Okay, so we need to be able to remember 1, 2, root 3. 1 is the shortest, 2 is the longest, root 3 is medium. So I have t is to 2, as 10 root 3 is to root 3. Okay, so I've got two things I can do here. One, I've got root 3 over root 3. I can cancel those. So I have really 10 over 1. And I can multiply across diagonally and get t is 2 times 10, which is 20. Okay, number 17. Short leg is to 1, hypotenuse is to 2, long leg is to root 3. So I have v is to 2, as 8 is to 1. And I will cross multiply here and get v equals 16, and that's over 1, so just 16. Okay, here's a beta. It's a Greek letter. It's something that you'll see maybe in some future math classes. Here's your first introduction to seeing it in a math class. It doesn't mean anything special. It is a variable. Okay, so I've got short leg is to 1, hypotenuse is to 2, long leg is to the square root of 3. So I have beta is to 1, as 15 is to the square root of 3. Okay, so I've got this left side already solved. It's over 1. Okay, but on the right side I have an irrational number in the denominator, so I need to multiply the top and bottom both by the square root of 3. So I get 15 times the square root of 3 over, and the square root of 3 times the square root of 3 is 3. And 15 is divisible by 3. It goes in 5 times, so 5 times the square root of 3. Number 19 is another Greek letter that you'll see fairly often in classes in your future. It's a theta, which is T-H-E-T-A, theta. Okay, it's very often used as an angle measure, so it would be a variable as an angle, but still it is just a variable. It will never be anything to be afraid of. Your short leg is to 1, as your hypotenuse is to 2, and your longer leg is to the square root of 3. So we have theta is to 2, as 17 is to the square root of 3. Okay, so I can multiply that 2 across, and I can multiply top and bottom by the square root of 3. Okay, so I get theta equals 2 times 17 is 34, times the square root of 3, over square root of 3 times the square root of 3 is 3. And 34 is not divisible by 3, so I will leave my answer just like that. And our last one, the short leg is to 1, as the hypotenuse is to 2, as the long leg is to the square root of 3. So I get w is to the square root of 3, as 10 root 3 is to 2. So I can multiply this square root of 3 across diagonally, and I get 10 times the square root of 3 times the square root of 3, which is 3 over 2. So that's 30 over 2, and 30 over 2 is 15.